Hi, I'm Deirdre Connolly. I'm new at the Zcash Foundation, and already met Anna.
Yeah, sure. So actually, we wanted to show you before our presentation was shielded and all black we want to welcome somebody, and this is Zcash Zebra. Yay! Hello. So you asking yourself, what is that, and what are we presenting here, and like why do we want to present that? So there's a second node implementation in Rust. Yay! And why we need that is actually, I think Josh actually summarized that quite well. So we need an independent node implementation which provides more options for Zcash miners and users, which promotes healthy decentralization of the concurrency protocol as it matures. So this is actually a good summary of why we want a second implementation. Decentralization for nodes is always a very reasonable idea if we're in a decentralized community, right? So I'll tell you a little bit about the history. I'll tell you a little bit about the history of that and what happened actually. So what happened is that Parity and the Zcash Foundation partnered. So there's also some Parity folks here, so go and say hi if you see some. I assume they are okay with that. Partnered to build this consensus-compatible node in Rust. And what Parity did is they forked Parity Bitcoin to do a Rust Zcash option, and we use the Rust cryptographic libraries from ECC and the Rust community like some. And this was handed over now to Zcash Foundation for future development. So where can you find this implementation? It's very easy. GitHub, Zcash Foundation, and then Zebra. And we hope to have tons of Zebras running. So we'll have, if some of you remember, a Zeal, which is which is the mascot of us. So run Zebras, so we'll have a Zeal. So we want to run actually that node and see how it looks like.
So I'm running an instance that we just built off master. I built it last night. I didn't build it earlier. This is running on mainnet. It is the whole chain has been downloaded, so it's not much. I'm also running testnet over here, and it's sinking down slowly but surely. What else can we do with it? We have a pretty basic RPC at the moment. It's Bitcoin compatible. There's a lot of things in our RPC that are not current, that are in the Zcash G RPC that we don't have yet, but we plan on extending that extensively. You can do things like get the block count from your mainnet. Look at that. You can do things like get the connection count. We have 10 of them. Awesome. And get the difficulty, and you can do a couple other things, but not all the things. What's the best block hash? There we go. So that's running against our instance locally, connected, synced up with mainnet. So part of the goals of this project is, one, we wanted to have another implementation of the Zcash protocol because it's a protocol, it's not a single software project. We want to have multiple interoperable versions of this an implementation of the community protocol to make sure that they work together. Two, we wanted to do it in Rust because Rust is pretty awesome and it gives us all these memory guarantees that we just don't get in C and C++. And also, having been working with this project for about 4 weeks now, the tooling is excellent and really helps us to make dependable, reliable builds. And that just comes out of the box with Rust and Cargo and things like that. So some of our goals for this project are, we want it to be a high-quality, production, secure software project developed in the open source community. We will be working extensively with the Electric Coin Company and the rest of the Zcash community on zips. And for the time being, we're going to be following the protocol upgrade path. So we are already updated through sapling, and we have to start working on implementing the Blossom upgrades. And then beyond that, we want to work with our community developers, especially wallet implementers, to see what we can do for you to help make your lives easier to what you need from a node implementation. And then for our infrastructure and how we are running stuff, we want to have like a whole bunch of nodes running on testnet, but especially mainnet, as we upgrade the actual implementation to like 1.0 and beyond. So one of the things that I've been working on since I joined a couple of weeks ago is we want a robust build and deployment pipeline. So we decided to leverage GitHub Actions, which is in beta, so that we can expose what we're doing and building to the community all in one place. You don't have to go from GitHub to Travis to this thing to that thing. So far, so good. And one of the things that we're leveraging is we're starting to build our fuzzing corpus. If you're not familiar, fuzzing is a way of generating randomized data and shoving it into your instrumented application to try and exercise as many different parts of your application as possible. Try and find things like out-of-memory errors and other possible weird behaviors that you might not have thought of if you just were writing unit tests by yourself. So we have a very limited fuzzing corpus already, and we are trying to shove that into a continuous fuzzing infrastructure, a instance of clusterfuzz, to automatically get that running every time we merge to master. And also we have automated dependency update checking via a nice bot that is provided by GitHub, because our dependency graph is large and very intertwined, and you really want just someone to tell you that you have a new update ready. Let's see, I'll just show a little bit what we're doing. So this is the actual repo. This is live on GitHub. You can get our whole RPC documented over here. It is not as robust as Zcash, but we're working on it. So when you open a pull request, which I did this morning actually, because Strad helped me fix a bug, and that's one of the nice things about Zcon is I can sit with all the people in the community, and he actually helped me fix something in a few hours as opposed to a few days. And this is a build that ran successfully in 22 minutes, which is much, much better than our previous builds of 45 to 50 minutes just for some simple change. So I was very happy to get that working. And this is what's actually being run when you do that. So we have a Docker container, and it runs all of our tests in debug mode, and then it compiles the entire the daemon in release mode. So this is a full runnable thing that you can spit out. And then if we're on master, we tag that, push it up to the container registry in Google Cloud. And for now, we're building our fuzzers and shoving them over to clusterfuzz. But the next step is to take that container, make nice and small and runnable. They're currently kind of fat, and they're like 3 gigabytes a piece, which is just, it's a big project. And running that either on a Kubernetes cluster or a different serverless sort of runtime. So, yeah. So our goals for the near future is obviously upgrading to Blossom. We have to just work on that ourselves. We are working with the dzip discussion as well as everything that's going into the network upgrade 3. We are running against mainnet in development only. This is an alpha project. We don't recommend people to run against mainnet for reals yet, because we're not to 1.0 yet. So our near-term project is to get to 1.0 and be running regularly against mainnet. We want to hear from our wallet developers and see what you actually need from our PC, because we don't want to just it be like a cluster of, grab bag RPC methods because someone thought it might be interesting one time. We want to keep it, we want to reduce our attack surface as much as we can while also being useful to other developers. Obviously, we want to expand our fuzzer coverage. We're fuzzing our hash functions, which is a very easy thing to fuzz. You just give it random data, and it spits out random data. If you have experience writing fuzzers, please come talk to us, because we would love to try and get that get as much coverage as we can. And then there's some other tools in the cargo area that are sort of expansions on regular fuzzing. There are some side channel fuzzers that we want to experiment with, as well as some constant time analysis tools, and specifically on a bunch of our crypto operations. We would like to see if those are useful to us.
So this is a call to action. So hi community, it's an alpha software, run Zebra. Try it out, open issues, give us feedback. We're at Zcon, so we're here throughout the whole conference, as you might have assumed. And so we're happy to talk to everybody who runs a Zebra. And if you're interested in contributing, we're also happy for that. It's an open source project, and you saw where it is. So we're happy if you just want to contribute a pull request, we're going to review it and have a look at that. And also we'll have contributing guidelines, which we work on at the moment, which are very important to us. So you'll see that up shortly. And we also want to talk to wallet developers, as Deirdre mentioned, or to anybody else who is going to wants to run that in their own thing. So what do you need? How can we help? And talk to us. So call to action. We're here. Hi. And we're also on Twitter. And you can also connect via email if that's your preferred way of connecting. So this is from our side.
Thank you.
Thank you.
We have time for questions.
Questions, if yeah.
Cool. Thank you.
Cool.